Okay, so then some of this clip, we're going to talk a little bit about ordered pairs and relations, and then we're going to see how to determine if an ordered pair is a relation, if an ordered pair or relation is a function or not. Okay, we're going to be taking a look at them by looking at examples and non-examples, all right? So let's start out by writing down what the definition of a relation is, okay? So what on earth is a relation? All right, so a relation is basically a set of ordered pairs. So a relation is a set of ordered pairs. Okay, ordered pairs. All right, and then there are different systems or forms for expressing a relation in mathematics. All right, we're gonna take a look at just four formulations in this clip, and then we're gonna see how we can identify if each relation is a function or not. Okay, so the first one we're going to take a look at is the set form. Okay, I bet you have seen this before. So let's write that down. The set form of a relation. All right, the set form of a relation can be given as follows. I'm just going to give you an example of a set form of a relation. Example is something such as this. You have a squiggly bracket to open the set of ordered pairs. 1, 3. That's the first ordered pair, comma 2, 3. That's the second ordered pair. Okay? So this is the set form of a relation. All right, what about the mapping form? Mapping form. Mapping form just involves creating a map of the inputs to the outputs, okay? So let's say we have something like this. We have two maps. Let's take an example. This is how it looks like in most textbooks. You have a map here. It could be like an oval, something like this. And we have a set here and a group of numbers here. So this would be the x's, and this would be the y's. And on the x, I'll have 1, 2. And on the y, I have 3. And basically, this mapping basically maps each x to a corresponding y. So this one gets mapped to 3, and then this 2 gets mapped to 3. So this is an example of a relation. In this formulation, the arrows basically indicate what pairs are being matched to each other. Okay? So 1 and 3 form an ordered pair, and then 2 and 3 form an ordered pair in the mapping form. All right, let's take a look at the graphical form. Graphical form. Graphical form of a relation. In this case, we're just going to be looking at graphs of points, right? Graphs of points basically illustrate that nicely for us. So I'm going to make a coordinate system. We're looking at ordered pairs, so we just need two axes, the x and the y. So this is my y, and this is my x. And I could have, let's call this 1, 2 for the x, and then 1, 2, 3 for the y. I can have a point here, 1, 3, and I can have another point here, 1, 3. So this is a graphical form of a relation. Okay, the intersection of each x and y value tells you what a relation is. So for this point right here, this is the input, that's the output, that's the first relation. And then for the second point here, this is the input, and that's the output, that's the relation. Okay, so you have two ordered pairs for this form. And then the last form I want to show you is the tabular form. The tabular form of a relation. Okay, this is normally what is used to generate the graphical form, right? Whenever you want to generate a graph, it's very beneficial, easy to make a table first, so you can easily associate each x with the corresponding y while graphing, right? So tabular form, you have a table, as you might have thought. Let me make that straight. You have a table, and then you have your x's and your y's, x and the y. Okay, so you have 1, 3, and then 2, 3. So each each row basically shows you an ordered pair or an association, okay? Each row tells you that. So you see this first row right here, 1 and 3 from an ordered pair, and second row right here, 2 and 3 from an ordered pair. So that's a tabular form, okay? So another thing to note when looking at a relation is the whole idea of domain and range, okay? So domain, okay, let me change this. Um, Domain of a relation is not really complicated. The domain is basically the set of x values. Okay? Alright, sorry about that. So the domain basically is the set of x values. Okay? The set of x values. Alright? So if you take a look at all these four formulations that we considered here, what are the domain here? So you have 1 and 2 here. That's the domain, because those are the x's. You know, for this ordered pair, the x's come first, right? So this and this, that's the domain. And then in the mapping form, 1 and 2 are the domain, okay, because they are the set group of x's. And here you have the only x values that have a point are 1 and 2. And then here your set of x's are 1 and 2. Okay, so in this examples I gave you, the domain is basically 1, 2. All right, if you wanted to write it, d is basically going to be 1 and 2. All right, it's not an ordered pair, it's a list. All right, so that's what domain is. For if you have a relation, the set of x's basically represent your domain. All right, how about range? What on earth is the range? Since domain is x, guess what? For the range, for ordered pairs, is going to be the set of y values. All right, the set of y values basically generates the range of your relation, okay? So in this case, we just have one element as the set of y values here. It's 3. If you look at this formulation, the ordered pairs, 3 is the only output. And then here you have 3, and then that's 3. And then 3 is the only output that these points correspond to. So in this case, the range basically is just 3. Okay? So there you have it. The domain is a set of x's, and range is a set of y's. Okay, another way to look at it, if it were a function, you can call the domain the input, and your range the output. Okay. So relation basically associates each input with the respective output. Alright, it tells you that when you input 1, you get 3 as an output, and when you input 2, you get 3 as an output. So that's another way to look at the whole idea of relation, input and output. Okay? Alright, so function or not. When is a relation a function? When is a relation not a function? We'll start by taking a look at what the definition of function is. And then we're going to look at some examples and non-examples. Alright? So, concerning, within the context of ordered pairs of relation, when is a relation classified as a function or not? All right, a function is a relation. It is a relation where each x value is that let's fix that where each x value where each x value is paired with exactly one y value. Okay, so for every input, you must have exactly one output. You can't have one input going to 2 different outputs. Okay, that doesn't work. So each x value has exactly one y value. Okay, one y value can have multiple x values, but each x has to have only one y. All right, so that's what it is to be a function. That's what it is for a relation to be a function. Okay, so let's take a look at this definition in the context of the formulations I just showed you. Okay, let's start with the set form. Okay, when is a set form a function and when is it not? I'll give you an example and then I'll see if you can figure it out. Okay, so let's take a look at this example, example 1. Example 1. What if we had this set? Consider this set right here. 1 comma 3 and 3 comma 7. Now when you're dealing with set form, this is what you watch out for. Repetition of x's. Repetition. Let me spell it correctly. Repetition of x's. Okay? Whenever immediately you see repetition in the x's, you know automatically that is not a function. Repetition of x's. Okay? So in dealing with set form, if you notice any repetition in the x's, it's not a function. Look at this. You have 1 and 3 as a set of x's. They are different, they're distinct. There are no repetitions here. So guess what? This is good. This is a function. Alright? So in ordered pairs, look for, on a set form, look for repetition in the x's. Okay? Let's take a look at another example. What if we had the ordered pair, the set 3, 7, comma, 3, 5. Now, is example 2, is this relation a function or not? You notice that the x's are repeated here. Guess what that means? This is not a function. No, not a function. Not a function. Okay? So that's the trick for ordered pairs. For set form, which is a set of ordered pairs. Repetition in the x is not a function. No repetition, function. Okay? All right. Now, how about the mapping form? Mapping form. How do you know that a map of a relation is a function or not? Well, there's a key word I want you to keep in mind when you're dealing with that, which is split out. Okay? Split out. What on earth does split out mean? I'll show you in a minute. Split out. If you have a map going out of the input and it splits and goes to 2 different outputs, guess what? It is not a function. All right? All right, so let's take a look at an example. Example 1. What does split out look like? Consider this relation, okay? We have a set here of the x's and a set here of the y's. X and y. Okay? You have 2, 3, and then 4, 5, 6. Now, if you know, let's say the mapping went like this. This to that, and then this to that, and then this to that. Okay? So this is in and this is going out. If you notice right here what's happening, there's a split going out. Whenever you have a split going out, you have one x value being assigned to 2 distinct y values. That is a no-no. You can't have a split when going out. Okay? Split out like that, that's totally wrong. So this one is not a function. Okay? This is not a function because you have one x value going to 2. Alright, let's take a look at another example. Slightly tricky. Let's see if you can get this one correct. Let's see for the x's, you have 1, 3, 4. And then for the y's, you have 3, 2. And you have this going to 3. And then 3 going to 3. And then 4 going to 2. Alright. Now take a look at this. Is this a function or not? Well, let's look. Do you have any splits when you're going out? One stayed uniform, stays as a unique arrow all the way out. 3 down. Okay? You have 2 going to 1, but you don't have 1 splitting. So guess what? This is a function. Is a function. Okay? That's why I said splitting out. When you're going out and there's a split, that's not a function. But if you have one x, maintain that one arrow just to one y, that's perfectly fine. Like this. Okay? So y's can have multiple x's, but x's cannot go to multiple y's. Alright? So this is a function right here. Alright, so keep in mind for set form, repetition, for mapping form, split outs, okay? How about tabular form? Well, tabular form turns out to be something similar to what we already know. Alright, so let's take a look at the tabular form. So for tabular form, all you're looking for is, guess what? Repetition in the x, okay? Just like the ordered pair, repetition. Repetition in the x's. Okay, if you see a table with repetition in the x's, that's automatically not a function because you're going to be associating one x to multiple y's. All right, so repetition is a no-no. All right, let's take a look at an example. Example 1. What if we had this table right here? You have xy, and then you have 3, 3, 5, 7. So you see this relation, 3 goes to 5, 3 goes to 7. Look at the x's. Are there repetitions? Yes, you have repetitions here. So guess what? This is not a function. Okay? Not a function. You understand why, right? The function has to assign each x to a unique y, but you're having an x right here being assigned to 2 different y's, which is a no-no. Okay, like a split out. All right. Now let's take a look at another example of a tabular relation. Example 2. Let's see if it's a function or not. Okay. So we have xy, we have 2, 5, and then 3, 3. All right. You notice there's a repetition in the y, but does that mean that this is a function or not? Remember, all you care about is the inputs. The x's has to go to exactly 1 y. We don't care about the number of y's here. So are there repetition in the x's? No. No repetition in the x's. Check. This is a function. Okay, it is a function. So this is perfect. This is good. All right. All right. Last but not the least is the graphical formulation. All right. So let's write it down. We're gonna look at the graphical form. Okay. So if you have a graph of a relation, how do you know if it is a function or not? Well, there's a special test for that. Let's do a real quick recap. If you have set form, look for repetition in the x's. If there repetition in the x's, then it's not a function. Mapping form, if you have a split while going out, you have one x going to multiple y's, that's automatically not a function. And then for tabular form, if there repetition in the x's, just like the set formulation, that's not a function. For the graphical form, you're going to have a special test called the vertical line test. Okay, vertical line test. All right. So if you draw a vertical line through all the ordered pair, through all the points, if it cuts through more than 1 point, then it is not a function. Okay. So let's take a look at an example. Example 1. Consider this set of ordered pairs in graphical form, and let's see if it's a function or not. Okay, so have that. We have a point here, 1, 1, have another point here, and then you have another point here. You just have 3 ordered pairs. Now, is this a function or not? Now, we're going to do the vertical line test. If a vertical line cuts through more than 1 point, it's not a function because that's telling me that 1x is getting multiple outputs. All right, so let's do it. So this first point, I'm going to draw a vertical line through the first point. Did it go through any other point? No, so that's good. Vertical line through the second point. Does it cut through another point? No, that's good. Third point, vertical line through there. Does it go through another point? No, that's excellent. So since all the vertical lines go through the points exactly once, that's good. This is a function. Okay, check is a function. All right, you know what this means, right? It tells you that each x, so 1 is getting outputted to just exactly 1, 2 is getting outputted to exactly 2, and 3 is getting outputted to exactly 3. Each x value is being assigned a unique y value, so that's what a function is all about. All right, let's take a look at another example. Take a look at another example. Example 2. Let's see. Here's catching up. Example 2. What if we have a relation given by the following given the following graphical form. Okay. Well, if we had a point here and 2, 1, point here and 2, 3, and then another point here. So let's say this is 2, and that's 4. This is 1, and that's 3. Now, oh, I didn't label my axis here. Sorry about that, y-axis. All right, so let's see. Is this a function or not? So what we're going to do here is simply do a vertical line test, okay? Vertical line through all the points. If it intersects more than once, then it's not a function, okay? So let's do this first. Bam, only 1 point. That's good. a vertical line through this point, it goes through 2 points. That's a fail right there. A vertical line must go through exactly 1 point in all the entire domain in order for it to be a function. The fact that this vertical line goes through a point here and a point here, that's a violation right there. Okay, that is a big problem. So because of that, this is not a function, not a function. It fails the vertical line test. Okay, what on earth does this mean though? It means that 2 is being assigned to 1 and 3. Is that acceptable in the definition of functions? No. Each x has to be assigned exactly 1, but this is being assigned to 2 outputs, which is a no-no. Alright, so this is not a function. Alright, so that's that. Thanks so much for watching this presentation. Please subscribe to my channel so you can get more updates and cool videos such as this, and do share with your friends. Also, you can feel free to request videos in my comment section. Collection of clips can be found on mathgotserved.com. Thanks again and have a wonderful day.